Hey, welcome Abhishek. So in today's mock interview round, we are taking PyTorch interview questions for generative AI engineer. And let's get to the next question. So the question is, so the next question is, how do you optimize PyTorch training for large models or large data sets, especially for LLM related or generative workloads?
Okay, so for this particular situation, I would approach this problem statement at two levels. One would be compute, other would be memory. So for compute, mixed precision would be used. That would typically give 1.5 to 2 times of the throughput with minimal code chain. For memory, gradient accumulation, it can be used. It will let me simulate a large effective batch size across multiple micro batches before, stepping the optimizer, and then go for gradient checkpointing to recompute the activations during the backward pass instead of, storing them. So, it would be like you know, uh, saving some extra compute by doing so. On the data side, I would, set the number of worker appropriately and use the prefetching to keep the, GPU fed. For LLM fine tuning, specifically, I would consider the methods like, LoRa or to reduce the trainable parameter. So I mean, with the project which I did was using the, Apple Silicon chip. So what I did as an optimization part, I disabled the pin memory. It's like a, device specific trade-off. So yeah. Yep. So, but this last point, disabling the pin memory was related to the, MPS specific constraint. So MPS is something which interact with PyTorch on the Apple Silicon chip, just like CUDA and all. So yeah.
Okay, great. Coming back to the next question. So the next question is, how would you fine tune or adapt the pre-trained transformer model in PyTorch for text generation in an enterprise use case?
Okay. So as per my experience, in my project, I fine tuned that digital GPT-2 on the CNN Daily Mail dataset for document summarization. The pipeline started with consistent tokenization. The same tokenizer config must be used at the training and inference time. Otherwise, the model vocabulary is assumptions uh, would break. So I uh, I format the input in, let's say, article colon and some text or summary, and then use some, casual language modeling loss. So evaluation goes beyond the loss. So I compute the rogue L score against the reference summaries and use them as the release gate in CI. So if rogue L drop below the threshold, the deployment will be blocked because that's the evaluation constraint. For enterprise use, I will also consider, inference latency as a parameter, the output length control, and the prompt design for the domain for which, we are making the project. If resources are constrained, then I would use LoRa to, fine tune only a small fraction of parameter while maintaining, at least, if not high quality, at least, maintaining the quality of model whatever we have. So yeah, that's how I
Okay, great. Coming to the next question. So the next question is, how do you verify that a PyTorch generative model is actually performing well and not just producing visually or linguistically plausible outputs?
Okay, for this particular thing where we have to verify, so the verification can be done in a layered approach. So for summarizer, I would compute a rogue L on a held out test split from data, and then manually review a random 20 sample subset for hallucination and factual drift. Metrics alone miss this, so that's why I would be using this approach. For the VAE anomaly gate, I would inject a synthetic anomaly and measure the precision and recall, then calibrate the construction error threshold to balance the false positive and false negative in this context. So critically, I would define the acceptance threshold before training start and use them as as gate in the CI and continuous integration. So this would prevent a post hoc rationalization of weak result. We can also go for run a regression test comparing each checkpoint against the current production best. So the performance improvement would be verifiable and the regressions are caught automatically on each iteration. Yeah, overall, yeah, the stress would be on threshold, which I said before training. So yep, that's how I would be doing.
Okay. Okay. Let's get to the next question. So the next question is, what PyTorch specific considerations matter when moving a generative AI model from experimentation to deployment?
Uh, so here, first step would be separating the inference from the training code before we do anything. The serving path, should only load weights, then run forward uh, with no gradient, and then handle the pre-processing, post-processing consistently with training. So I would serialize the state dictionary rather than pickling the full model, and pin all library version in the requirement file of the project to avoid a silent regression. For real experience, uploading checkpointing large PT files to HF Hugging Face space required uh, using some commit operation add from Hugging Face library, because the standard upload file method respect the git ignore and would silently skip them. It would be a non-obvious failure. So post deployment, again, rogel, and I would monitor rogel on the incoming sample, the latency percentile, and the memory uses with the rollback strategy tied to the previous version checkpoint. So overall, the commit operation uh, is a concrete trade-off here for this particular situation.
Okay. Okay. And how do you ensure model serialization?
For this context,
Hmm.
definitely, we would be, saving the states in some kind of dictionary,
Hmm.
a state dictionary, uh, which would, save the weights, not the class definition. So it would be kind of a portable file,
Hmm.
which would be having, all the states
Hmm.
of the model,
Okay.
and we can, I mean, we can use any of the model
Hmm.
from this. And the other would be, saving the entire model object. So yeah, that we can also do, but mm, it would be fragile, if we rename the class or move the file or something.
Mhm.
So that must not be done in production.
Mhm.
So I would be going with the state dictionary.
Okay. Okay. Sure. Let's get to the next question. So the next question is, describe a time when your PyTorch model results were not reproducible. How did you investigate and fix it?
Okay. So uh, what I observe in the project, I encountered a subtle issue where the the variational autoencoder produced inconsistent anomaly score at inference. So after investigation, I found there was a config mismatch. The training script saved the checkpoint as some name, but the inference loader expected some some different format of that .pt file, the name format. So it was a silent failure that loaded some random weight instead of raising an error. So I fixed this by enforcing a consistent naming in the config.yml. I added a config.yml and you know put a consistent naming strategy there, and adding an explicit assertion that loaded a checkpoint matches the the expected value. I also set a manual seed and random seed at start of all the script and pinned all the library version and the requirement file. The broader lesson was reproducibility need to be designed into the workflow from start. Config tracking, explicit checkpoint validation, randomness seed. Uh, mm, so it need to be done initially, not when your result differ post the output is generated.
Mm. Okay. 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 And can you explain me how we can enable determinism in such cases
Determinism in what sense?
in PyTorch? I just want to understand any methods which are there which can ensure deterministic behavior of algorithms.
Uh, uh, you were, I mean, what you are referring to is you're referring to reproducible nature of the code.
I just want the behavior of the algorithm which I'm considering should be deterministic. It should be predictable. It should not be unpredictable. So how we can do that in PyTorch?
So we can give the manual seed.
Mhm.
So it would control the random number generation, kind of weight initialization,
Mhm.
and there are certain parameter. I am not getting the name. Those need to be set true for for deterministic nature
Okay.
within the PyTorch,
Okay.
and so it would force the PyTorch to use deterministic implementation and would raise an error if no deterministic version exists for that particular operation.
Correct. Okay. So you can use manual seeds, and there is one more method which is use deterministic algorithms. You can set that to true.
Yes, yeah,
That
and
that
there's yeah, this one, and there's one more, but yeah, these two are the main thing.
yeah. Okay. Coming back to the next question. Okay. Suppose if a TCS client asks you to explain why a PyTorch based generative model should be trusted in production, how would you communicate that to both technical and non technical stakeholders?
Okay, so for this situation, for a technical audience, I would walk through the evaluation. The model was validated on a held out data. It never saw which it never saw. So the rogue L score exceed the defined threshold before deployment, and our VAE normally gate reject a suspicious output before they reach the summarizer. So I would describe the CI gate and rollback path. For a non-technical business client, I would say the system has been tested on hundred of real documents, and it performs well on standard summarization tasks. But like any AI system, it can make mistake on unusual input, which is why we have built a safety layer that flag low confidence output for human review, and we monitor quality weekly. So I would avoid, claiming that the model is always correct, and instead I would emphasize on operational control that bound its risk. So not to overpromise, maintain some balance on each factor.
Okay. Okay. Let's get to the next question. So what coding and review practices do you follow in PyTorch projects to support CI/CD, maintainability, and team collaboration?
Okay, not just PyTorch project. I mean, for any project, engineers should follow a modular code structure. Separate directories for data loading, model definition, training, evaluation, serving, and test. All hyperparameter and file path should live in config.yml, and it should be there in any project. No magic number in the code. So everything is already, preceded. Uh, for CI on GitHub Action, I would run smoke test on tiny data slice first to catch the, import and shape error, and then would validate the model artifact load and, the output expected shape. And then the gate merges the rogue L threshold. For large checkpoint files, are managed with the, obviously these are large, right? So git LFS would be used on GitHub, and those are, uploaded to the Hugging Face space via some, commit operation at to bypass the git ignore restrictions. Dependencies are would be pinned exactly as per requirement.txt, and it should be finalized at the initiation. The code goes through review, before merging. Focus would be on training loop correctness, data handling, and configuration consistency. So yeah, these are all kind of amalgamation of good practices for any project, not just PyTorch project,
Okay.
which
Can you
need to be for.
Okay. Can you name a few linters which are used, which you can use to consistently follow code styles?
Uh, for this project, so I mean, what I used was PyLint here. I mean, that is the default thing which I use.
Mhm.
So PyLint was used, mm, to catch the logic error or some bad practice or some bad code.
Okay.
For type checking,
Mhm.
for I mean, in VS Code we use Pyrite, so it's equivalent to MyPy.
Okay.
We check the code by default.
Okay. Any idea about
Yeah.
Flake 8 or Black Lint?
Flake, yeah, it's I mean, it check the PEP 8 style
Mhm.
of code, the Flake 8, and check all your variables, and if it is defined, not defined, whatever you have imported is present or not present.
Mhm.
So it's common, I mean, in data science project.
Okay.
But I was working on this VS Code, so I use Pylint.
Mhm. Okay. Sure. Okay. Great.